All right, here we are. I feel like I'm a little bit out of focus. Let's see. That's better. All right, hey guys, this is Mrs. Lyons. This video will go over day 5 notes, and this is a pretty straightforward concept. It's just like you would calculate percent of anything. You know, what is your grade in class based on what was your grade on the test? You know, how many did you get right divided by the total? Okay, so we can actually calculate the percent composition of a chemical compound based on its mass. Okay, there are other ways you could calculate percent composition. For example, you could just simply count the atoms. So in H2O water, there would be 2 hydrogen and 1 oxygen, so it would be 66% hydrogen. However, that really doesn't do us any good because the masses of each atom are so different. What will do us good and help us is to calculate percent by mass. And this is actually something that when I worked in the lab, that this is one of the things in chemistry that I did on a regular basis. If you send a compound out for analysis, what they do is they do an experiment with the compound where they combust it, they burn it, and then they calculate how many, what percent of each element is present. And then they send you back the data and you can see, did I make the compound I thought I made, or did I make something else? So just this is just one of those things that actually is used in the lab. All right, so let's see, percent composition. Percent composition is, let's write this. Percent composition indicates the makeup or composition of a substance based on mass. And this is one of the easier, again, easier concepts. So if you were looking at data, you might see this compound is 50% carbon by mass. Okay. All right. So what we're going to do, the way that you do this, if you want to calculate the percent of a given element, what you do is you take the mass of that element and you divide it by the mass of the compound. And just like any percent, you're going to multiply by 100 to get the percent. Okay, now one thing to note, when we say the mass of the element, this means the amount in the compound. Okay, and that's not to be confused with the mass on the periodic table. And we'll look at this first example. And it will help us kind of see what I mean when I say that. Excuse me. All right, so what is the percent lithium in lithium oxide? So what you've got to do first is you've got to calculate the molar mass of the compound. Okay, so I have 2 lithium and 1 oxygen. And again, I still don't have my paper periodic table. Excuse me. So the mass of lithium on the periodic table is 6.94, and the mass of oxygen on the periodic table is 16. So let me get on the calculator, and if I do 2 times 6.94, I get 13.88 plus 16 gives me a molar mass of 29.88 grams. All right, now to find the percent of lithium, what I do is I take the total mass of lithium. Okay, so I don't take the mass of one lithium. In this case, I take the mass of 2 lithium because there's 2 lithium in the compound. Okay, so I would do the mass of lithium, so 13.88 divided by the mass of the whole compound, 29.88 times 100. So let's see what we get. 13.88 divided by 29.88 gives me 46.45%. Now, just a note, when we're doing percent compositions, we're taking all of our masses off of the periodic table. So sig figs don't necessarily play a role in this because different periodic tables have different values or different number of digits, certain specificity. So what I want you to do for all of these percents is just use 2 places after the decimal, because on our periodic table, I believe all of the elements, all of the molar masses go to 2 places after the decimal. All right. All right. So let's do another example. Now this one, and this is another case of make sure you're reading the question, because this one asks what is the percent of each element in barium arsenate. All right. This first example up here just asked you for lithium, and I can't tell you the times that on a test I'll ask for a certain element and students don't read the question, they just give the percent composition of every element, which is more work than you have to do. So let's look at this barium arsenate. So let's see what I've got. I've got 3 barium. And then this arsenate, ASO4, I have 2 of those. So I have 2 arsenics. And I have 8 oxygens. Another note here, it's really important when we start doing these calculations that you get the right number of atoms. If you don't, it's going to throw absolutely everything off. It's also really important to show all of your work so that if you do make a mistake, I can see where that mistake was made and give you partial credit. Okay, so barium has a molar mass of 137.33. Arsenic has a molar mass of 74.92. And oxygen has a mass of 16. So let's do some math. Whoops. All right. So 3 times 137.33 is 411.99. 2 times 74.92, 149.84. 8 times 16, is that 144? Oh, did I do that right? 8 times 16, 128. guess that is right. 128. So I'm going to add all of those together. And I get a molar mass of 689.83. 689.83 grams. Okay, so to get the percent of barium, I'm going to do 411.99 divided by 689.83 times 100. To get the percent arsenic, I'm going to do 149.84 divided by 689.83. And for the percent oxygen, I'm going to do 128 divided by 689.84. And then I've got it all set up. Now I'll do the math. So 411.99 divided by 689.83 tells me that my compound is 59.72% barium. Arsenic is 21.72%. And oxygen is 18.56%. Oh goodness, I don't know if you hear that. My puppy is getting all wound up in the living room. Okay, now that I've got these percentages, one thing you certainly know, hopefully by now, is that if you add up the percentages, if you include everything, you should get a sum of approximately 100, really close. So let's just double check our work. 21.72 plus 18.56. Oh, exactly 100%. Okay, so if you do that little check and you come up with a number that's off by more than 1 or 2 from 100, you might want to go back and recheck your work. Something else in this unit that I'm going to ask you to do, and I guess I didn't do it up here, I guess I did on my final answer, is put a box around your answers, because as you can see, there's going to be lots of math that we're doing, and it's easier for me to figure out. Sometimes people will you'll do a problem twice, you'll do it wrong, and then you'll fix it and you'll do it right. Box your answers that I know which answer you mean for me to take as your correct answer. All right. Hopefully not too tough of a concept. I will see you in class. Have a good day.